Okay, let us see this question. They say a position vector of a particle is given by that at any time t. Find the velocity and acceleration of the particle at any time t. And then B, show that the speed of the particle is constant. Then show that the directional acceleration of the particle is at right angles with r. So in simple terms, we start by u that operates in r solution. We know that r velocity is equal to the displacement, derivative of the displacement, and then our acceleration is equal to the derivative of the velocity. As simple as that. So to get the velocity, rv now is going to be d, the r, the t, because they are giving us it in terms of r. So mean that now this will be equal to 2. So remember our displacement, so our r, I can write it as a vector form, as sine 2t, and this is going to be cos 2t. So meaning this will be now the derivative respect to t of sine 2t, then cos 2t. So from here, my velocity at any time t is going to be, when you differentiate this now, if the angle is not 1, we first differentiate the angle. When you differentiate this angle is 2t. When you differentiate 2t, you get 2. Then you get the derivative and multiply it here, and then you differentiate sine, you get cos of that same angle. So that's why here I have 2, then cos 2t. I differentiate the angle, I get 2, and then I multiply it there. When I differentiate this angle, I get 2. When I differentiate cos, we get a negative of sine of that angle. So that's the velocity at any time t. Of course, it's not being meters per second. Okay, to get our acceleration, say the acceleration will be equal to 2. We differentiate velocity. So this will be the derivative of 2 cos 2t, then negative 2 sine 2t. Okay, when you differentiate this, we shall get, when you differentiate this, we get 2, then this 2, multiply this, so we shall get, but when you differentiate, of course, we get a negative. So we get negative 4 sine 2t. When you differentiate this, we get 2, when this 2 multiplies here, we get a negative 4, then cos 2t with ease. This is our in meters per second. This is our acceleration at any given time t. So we have everything there. It is. And then they are telling us that, or if you want, you can give them as in the IDK notation, no problem. Show that the speed of the particle is constant. So that's our part A. Then our part B. Know that always the speed of a particle is given by magnitude of its velocity. So, can we get the magnitude of this velocity? So this would be, remember, our velocity at any time t was 2 cos 2t, then this was negative 2 sine 2t. So this would be now the square root of 2 cos 2t, the whole squared, and plus negative 2 sine 2t, the whole squared. So this will give us the square root of, when you square 2, we get 4. When you square this, we get cos squared 2t. When you square negative 2, we get a 4. When you square this, we get sine squared 2t. So start from there. When you factorize out a 4, you see that R4 is common. When I factorize it out, I mean with cos squared 2t plus sine squared 2t. But you know that orange, this one from first identity of 3, this is 1. Cos squared of any angle plus sine squared of any angle. I mean of the same, these angles should be the same. This is 2t and this is 2. So they have the sum of the squares, then that is a 1. So this would give us 2 meters per second. So whatever time we are going to be with, acceleration is going to be, because you see, for any time t, the acceleration is going to be, the speed is going to be that. So the speed is 2 meters per second at any time t, as simple as that. Then part C, show that the directional motion of the particle is at right angles. At right angles, it means, this is what they mean by at right angles. At right angles. So they want us to show that they are perpendicular. How do you show that two vectors are perpendicular? Show that two vectors are perpendicular if their product is 0. So direction of a particle is given by its velocity. Direction of motion is equal to the velocity. So, meaning, if I dot the direction d times r, I should get a 0 if they are perpendicular. If I have this d dot, if we dot them, we should get a 0. So let us see what happens there. So my d, the order velocity, which will be v dot r, which will be our v. Our v is 2 cos 2t. We are dotting it to 2 sine 2t dots with r. What was our r? Our r is sine 2t, then cos 2t. So let us dot this times this, we get 2 cos 2t sine 2t, then plus this dot this, we get negative 2 cos 2t sine 2t, which is going to give us, I think it's that this one and this one, they are the same, which is 0. So since v dot r is equal to 0, then they are at right angles or perpendicular. As simple as that. So that's how we handle that question. Most of the questions, when we have a sine and twin function with the same angle, acceleration is going to be constant, whatever time you have. Anyway, that's it, members. I wish you well.